Good morning, students. Myself, Ashagila Devi, Assistant Professor in Rohini College of Engineering and Technology. Today, we are going to discuss about the subject CCS 355, Neural Networks and Deep Learning. In today's lecture, we will study an important topic from Unit 1, namely Supervised Learning Network, which is perceptrons. The perceptron is one of the most earliest and the most fundamental neural network model, and it forms the basic for modern deep learning architecture. So first we are going to discuss about the supervised learning network. First, let us understand supervised learning. In supervised learning, learning takes place using labeled input-output pairs. This desired output is already known. So the network learns by comparing its output with the target output. So supervised learning networks are commonly used for classification problems such as yes or no decisions or class labeling. And what is perceptron network is a perceptron network was introduced by Frank Rosebalt in 1957. It is a supervised learning algorithm. It's mainly used for binary classification problems. One of the earliest model of artificial, it's one of the earliest model of artificial neurons. The perceptrons decides whether an input belongs to one class or another. Then about the types of perceptron, there are two main types of perceptron, single layer perceptron and multi-layer perceptron. These two types differ mainly in their processing power and ability to solve complex problems. So when we discuss about single layer perceptron, a single layer perceptron contains an input layer and output layer only. There is no hidden layer. This perceptron can learn only linearly separable patterns. It produces a simple linear decision boundary and it's suitable for basic classification problems. And when we discuss about multi-layer perceptron, a multi-layer perceptron contains one or more hidden layers, an input layer and an output layer. Because of hidden layers, it has higher processing capability. It can solve non-linear problems. It overcomes the limitations of single-layer perceptrons. So next we are going to discuss about the perceptron learning concept. The learning concept of a perceptron is very simple. The perceptron learns appropriate weights for the input signal. It forms a linear decision boundary and classifies the input into two classes, usually +1 or -1. The goal is to adjust the weight so that the correct classification is achieved. So when we discuss about the perceptron algorithm in single layer, now let us understand the perceptron algorithm for a single layer network. The main steps are initializing the weight, bias and learning rate, apply the input and compute the net input, update the weights and bias if there is an error, repeat the process until the network converges. So the initial step is, that is step 0. In initialization step, all the weights and the bias are initialized to 0. The learning rate alpha is chosen between 0 to 1. For simplicity, we can take the alpha value as 1. So this prepares the network for training. And next is net input calculation. The net input calculation of the perceptron is calculated as the net input is equal to summation wi into xi plus b. The net input is then passed to the activation function to generate the output y, where w is the weight and x is the input and b is the bias value. And next is weight and bias adjustment. After obtaining the output, the actual output y is compared with the target output t. If y is not equal to t, the weights and bias are updated. If the y is equal to t, no changes is required. So this process allows the perceptron to learn from its mistake. And what is a stopping condition? The training process stops when there is no further changes of weight is needed and all the training samples are correctly classified. So if the condition is not met, then the training steps are repeated. Next, we are going to discuss about the perceptron algorithm in multi-layer. For a multi-layer perceptron, the weight, bias and the learning rate are initialized. Net input and output are computed layer by layer. The weights are adjusted using error signals. The process continues until convergence. So this approach allows the learning of complex patterns. So what are the advantages of perceptron? So the main advantage of a perceptron are it's simple, easy to use and implement, and it's fast and it has a faster training process and it's suitable for basic classification task. But what are the limitations of a perceptron? However, the perceptrons has limitations. The single layer perceptron cannot However, the perceptron has several advantages. The single layer perceptron cannot solve non-linear problems. It works only for linearly separable data. These limitations are overcome using multi-layer perceptron. And when we'll discuss about the conclusion, that is to conclude today's lecture, the perceptron is the foundation of neural networks. It is a supervised learning technique and it forms the basics for advanced deep learning models. In the next lecture, we will study the numerical problems as well as the training examples on perceptron learning. Thanks for listening. Thank you.